Good afternoon, sir.
Good afternoon.
तुझं कर पण.
So let us continue with yesterday's topic, right?
Yes, yes,
Vi-
sir.
Vibration,
For
right?
second year.
Second year, right? So
Yes, sir.
yesterday
Okay, sir.
we have
Okay,
seen.
sir. You can start.
Can we start now?
Yes, sir.
Ha. So yesterday we just briefed about the system. What type of a system are there? Basic principle of measurement for vibrations. Then how fast Fourier transform and give the benefit to the maintenance engineers, where the fault is. So these points were discussed. We will go ahead now. Yesterday I was with the sensor proximeters. This is the actually vibration sensor probe, and this is the proximeter. In that there is the electronics like we seen yesterday that demodulator and oscillator is there. Uh, so we have seen yesterday few slides on this, and this is a simulator for simulating the probe, because this is a very precise probe, and it requires minus voltage. So standard our test bench, uh, uh, nobody provides the minus 17 volt and minus 26 volts. So this kit is always there for calibrating the vibration probes. So vibration monitor, it's a DC gap signal, AC signals. These are the measurements. So you will get a reading. Yesterday we have seen standard readings. What we are getting, alarm is at 2 mils, trips as a 4 mils for radial, and this is for axial. Axial vibration has some clearance, 15 mils and 30 mils. But radial means it has a very you if you see the construction, it has a no gap, more gap between casing and the rotor. So this is actually Bentley Nevada vibration monitoring system, where you can see power supply card, controller card, and then individual uh, these cards for particular probe, means radial or horizontal, radial, vertical, like this. Individual has. Then axial has this like this. So this is a dual redundant, means same is here. So in case this card fails, electronics fails, this is available. So therefore, you can see the similarity here in this. And then on DCS, you have a graphic of the compressors, and there the vibration readings are readings also coming from the sensors that they are particular. You can see here reading for the mils. You can see here range is 0 to 5 mils, and in that it is indicated 0.56 mils. So you can see on slightly same faceplate for vibration measurement on DCS graphics I'm talking. And earlier I have shown on Bentley Nevada system. So Bentley Nevada system is a dedicated system. However, for the operation per staff, same data is taken to the DCS graphics. So you see here on the DCS, this is the one of the probe for vibrations, where it is on present on manual mode, and 0.55 milli PV mils. Mils is a unit for the vibration is here, and this is the range which is shown. This is the what alarm comes, and this is a tripping range, which I have told XL has some tripping range, and radial has a different same thing. So you can see the readings on the vibration on the DCS side. At this point, 9.08, 15. So 15 is means this is axial side. These are axial sides. Radial side, you can see reading are less than 4 something. This one like this. Mhm. So this is how the industry set up, where automation system DCS, Bentley, a dedicated vibration monitoring system from reputed manufacturers. So you can see the graphic view on the workstation also. Same replica of Bentley Nevada is also taken on this. So various vibrations parameters at different stages are coming here. You see here graphic page on the workstation for vibration measure, the vibration data. Here, this is for process air compressor data. So process air compressor vibrations are measured on this. So typical online vibration monitoring system components. I'm coming to now a system. You see here. These are the probes. Sensors are mounted on compressor. This is a compressor. And your sensors are here. Just see here, here. I have seen some locations this side, here. So these are the sensors on motor, on gearbox, on pump. So here the sensors are mounted. So these are the sensors mounted here, and the sensors through this multi-pair cable junction box goes to the this rack. I have shown one rack of Bentley Nevada. So here this is the rack where the sensor data goes here for the individual location, means axial, radial, uh, either this is for various locations. You have seen so many locations we are taking uh, on vibrations. So means horizontal, vertical, like that. So this is the what actually dedicated system with the modular system. These are cards, power supply, controller, and individual cards with local indications, either analog indicators. Earlier it was analog indicators. Now we get a digital display of this here. Then this online system is connected to the DCS. This is your DCS network, and through Ethernet connectivity or RSA 485 or Modbus I'm talking, it is connected to the server, means we can say DCS server, and through this third party server goes to the DCS of whichever DCS you have, Honeywell, Yokogawa, Emerson, whichever DCS. So this is what. Hello, 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 hello.
Yes, sir.
I'm audible. Yeah, yeah. Okay. So this is the system. Tip- so typical online vibration monitoring system in the industry having these are the basic components, we can say. This is the equipment or asset of which we are measuring the vibration, and sensors, means proximity sensors, cables. They are very dedicated cables because as you have seen the very signal range is minus side, and then goes to the rack, and this rack is connected through Ethernet to the plant DCS. Now I'm coming to very important part. Now the technology changing with the wire, it has become wireless now. So wireless vibration system has been introduced long back, 4 5 years back, and this system has helped a lot, especially for uh, difficult to reach locations in the industry. Maybe high temperature, height, vibration is very high, noise is very high. So your maintenance is very difficult for a human being to reach to that. So sometimes we are missing the measurements or monitoring. Then the accidents happen because these are rotating equipments, and equipment get damaged. Sometimes casualties are also there. So the technology, new technology, means this wireless technology is helping a lot on this. So what is that wireless technology applications for the vibration, that we will see now, and how it is to be implemented. So just see here, as I told you, this is the what setup, motor, pump, and gearbox, this rotors, all these equipments. You can see the mechanical equipment mounted on this foundation bolts, and these are vibrating. So as you see, we always measure the vibration. We have vibration probes on the motor, vibration probe on this gearbox, vibration probe on pump casings. So these for your understanding purpose, presently you can see two vibration probes here, magnetic pickup type. This and these probes. These are magnetic pickup type probes, and these you see this application uh, here. These signals c- are collected on this transmitter, which is mounted nearby, and this transmitter will measure this value of the vibration and transmit to the control system or your whatever you have, suppose a dedicated system like I have shown you Bentley Nevada or typical dedicated system or DCS system through wireless. And you see this is the instrument which send the signal in the wireless hard format, uh, and it is collected on this gateway which is mounted somewhere nearby. So you can see here overall vibration unit range is 2 hertz to 1000 hertz, identifies problem like imbalance and looseness. Means if the range of the frequency is between 2 hertz to 1000 hertz per as per standard, the problem is imbalance or looseness of the bolt, means this foundation bolts or casing loose. Peak value vibration unit 1000 to 20000 hertz. Comments are quantify early bearing or gearbox defects in this bearing or gearbox. These are the bearings are inside. Then temperature range is minus 30 to 250 Fahrenheit or minus 30 to 120 degree centigrade when sensor with embedded temperature used. So on this you can measure temperature. You can have two vibrating parameters. One is looseness, like imbalance, and defects in bearing and gearbox is identified. And this signal goes to the through wireless format. So how it is reaching, that we'll see. So wireless vibration transmitter. This wireless vibration transmitter for rotating machines. Please note this is a semi-critical machines like pumps, cooling tower fans, thin fan coolers, and machines not having access to measure vibration due to the tight clearance. So accelerometer sensors are mounted on the machine casing. So as I told, I have shown the uh, type of sensor accelerometer, and we have seen proximity sensor. That principle is different. The transmitter are mounted near the machine. These transmitters communicate to the gateway on wireless HART up to 200 meters. Means you can mount transmitter away. This is 200 meters distance is the line of sight I am talking. Line of sight. So you can see this distance is 200 meters away from the gateway, and these are the accelerometers, accelerometer type sensors for measuring the vibrations. The transmitter measures the vibration in terms of velocity as per ISO standards. Peak view for bearing and gearbox condition and casing temperature optionally. So peak view for bearing and gearbox condition and casing temperature optionally, means this has a this much limited feature for this transmitter. So you, you can see here wireless vibration monitoring system, how it is installed and how it is functionally operating in the industrial environment. So you see here, AS means accelerometer sensors. So these are the accelerometer sensors. WVT, wireless vibration transmitter, means this. And industrial scientific medical band. So this wireless range, it is called ISM band. ISM means industrial scientific medical frequency. ISM band of frequency. So in the wireless heart, this band is no permission is required because it is ISM band. Otherwise, if you are using any wireless system, you require a military or permissions. So this is not under their frequencies. So frequency is between 2.4 to 2.483 gigahertz ISM band. So just note it, wireless signal range is 2.4 to 2.483 gigahertz ISM band. ISM is industrial scientific medical band, and this frequency is dedicated for wireless heart, and which is not harmful health wise, and not intercepting any military or police network. So it is allowed globally. So I was talking about these wireless sensors, accelerometer, transmitters. There are in this picture there are two transmitters because one transmitter has a two accelerometer you can connect. So you need four points for reading for this motor casing, and this for your pump. So then two transmitters are here, and these two transmitters transmit the signal on wireless frequency 2.4 to 2.48 gigahertz, and it is received at a wireless gateway here. This is a gateway, and in this gateway, these signals then through wire and even today wireless also goes to the DCS. So this is either you can connect through Ethernet to the exist PC, laptop, or you can connect serially to the serial or Ethernet both to the DCS. So in this picture there is a Emerson Delta V DCS, and this is a wireless maintenance station. So uh, nowadays wireless vibration systems are existing. My point was you should know about this. That was the my objective to give you this advanced picture. So now I will explain you adoption of IIoT means I'm talking about adoption of wireless technology, wireless vibration system. I will say adoption of wireless vibration system at RCF. But then I will uh, switch to the other presentation. So give me some time to switch to my presentation to the just a minute. So see here, adoption means how RCF has implemented this wireless vibration setup. So RCF, as you know, ammonia plant, urea plant is a big chemicals and fertilizer setup in India, and there is a basic requirement of water for process, chemical process, as well as we're talking many other means boilers and all. So this water has to be processed, and therefore uh, there are cooling tower. You can see here there are six cooling towers. One, two, three, four, five, and six cooling towers in these pictures. So you see these cooling towers, and then water here uh, is coming down, and the it is cooled using fan on top. On this tray you can see the fan is there and fan is rotating. And what is happening due to the height, and this is the uh, most of the structure is wooden structure is there. So always because of fan and all it vibrates because of height. So mainly operators or maintenance staff uh, ignores to go there, and that measurements we miss. So significant incident in cooling water fans are dislocating blades. So sometimes the blades like our fan get dislocated because of looseness of the bolts, fan bolts, due to excessive vibrations. So these events inevitably have a serious impact on a business. If suppose one of the fan not working, so definitely cooling water quality get degraded, and that way your product processing either require more energy, or quality of the product, or volume or quantity of the product decreases. So that is what these events inevitably have a serious impact on a business with the repair cost and loss of production. So frequent tripping up of plants and potential hazard. Hazard means many times accidents happens. This get collapse if you are not mo- regularly maintaining it. Sometimes it collapses also. So these are the and there are difficulties that it is not easy to reach at this location to check the vibrations or to check the status of the motors or fans and all. So that is the difficulty basically. Uh, there are vibration sensors, but whether they are working or any problem, so that was the issues. So basic principle you can see here. This way it acts. This is the what you have seen vibration. One of the vibration tower. This is the fan I was talking, and the blade get dislocated. These blades, due to the excessive vibrations. And you see this motor, and this is a rotor. So this vibrates. So vibration sensors are there on the here and motor also. And only difficulty was there. It is not properly maintained, and we were not getting a reading status of the fan, and that results to the, we can say, accidents. Hello. So here installation of direct vibration measurement of cooling water fans using wireless vibration transmitter. See, CSI and all these model number of immersion product. You forget about this. We are talking about the transmitter here, but this is the what transmitter you look as a immersion transmitter basically. But Honeywell has, Siemens has, many companies has. You can have of your own uh, budget and requirements of choice also. So this CSI 9420 wireless vibration transmitter is easy to install. Means you can see here the from accelerometer is a vibration sensor. The cable is taken nearby and is mounted on this wooden. You can see wooden framework, and there you can mount on this transmitter. This normal transmitter. It's like a normal transmitter. Only you can see the antenna here. You can see the black portion is the antenna, and y- this cable, blue color cable, carries the signal of vibrations of this tower, and actually now these wires are not at all required because you can you are getting signal through wireless, and therefore it is mentioned that easy to installation. Why easy to install? Just fit it and forget it. No cabling and nothing inside the wireless. You will ask me how the power is get. So there is a battery there. Through battery the power is provided. It has a battery inside it with a 5-volt battery and gives the power to the transmitter. So in the plant, you can see here uh, the transmitters are red dots, wireless transmitter, and inside that sensors are connected, and these are directly getting connected to this antenna. If suppose wireless is not there, then you can just imagine the cables for how you have to take from here, dig the road, carry up to this up to the control room this side and connect it. So it's a big job. Now it is only you are installed here and the signal is coming to this antenna here. I have shown in the one of the picture antenna and gateway. I am talking about this. Oh, gateway. I will show you gateway. So this gateway will receive the signal here. This is the gateway, and you can fit the antenna on the top of the building and just collect the signal. Antenna is connected to the gateway electronics, and the gateway is connected through Ethernet or through Modbus to the existing DCS. So you see how simple it is, and the signal flow. Just I will explain you now how it is happening. See here, transmitters transmitting the wireless in the wireless format in the frequency of 2.4 into 2.483 gigahertz range, and it is received by gateway. This is a gateway. You see, gateway means I am talking about a gateway electronics here, and this gateway is connected uh, to the serial interface card. Means the signal is coming here to in the Modbus format. That means Modbus format RS485, and this signal coming connected to the existing DCS serial interface card. Actually, here we have a DCS is from Yokogawa, and so it is coming on Modbus protocol. Output is there are two options, Ethernet and Modbus, but as this DCS version was old, it was not accepting Ethernet, it was accepting a Modbus. So here we connected on the Modbus, and a Modbus means serial interface card. RS232, RS4845, these are coming under serial interface category. So you can see here this card is there in the DCS, and then it is directly processed on the controller. This is the DCS controller where you can have a modular structure with redundancy. Power supply two cards, controller two cards. In this plant there are four controllers. Sorry, two controllers, but two means one redundant like this. So this is the what DCS control electronics and DCS controller electronics, and from here this vibration signal is processed here and connected to the graphic on this workstation graphic here through control network, DCS control network. As I told, this is the Yokogawa system, and in the Yokogawa DCS architecture, control network name is VNet IP. VNet IP, and this is a VNet IP switch, network switch, because there are so many nodes on this. So one of the node, this station is connected. So this is a VNet IP switch, network switch, and this the vibration is data is displayed on this, And you can see on a faceplate, this is the small faceplate of particular vibration of this fan, this tower fan. So you will get the value here. So how data is collected for monitoring in the wireless vibration, that is what it is shown here. You see here. This is the path. So while nowadays vibration measurement become very we can say, even though it is crucial. I told so many accidents happen now because of this. Uh, you can reduce the frequency of failure. So what are the benefits? Reduction in cable. The cable is not there. Erection material, because when we are cabling, you require structure for carrying the cable. So erection material, and thus in the size of control room. And you can see in the size there is control room size means in the control room no IO card, nothing is required. Simple through gateway, simple RS485 or Ethernet cable is going. So it is a revolutionary wireless network. Automation actually has the capability to reduce the process variability and increase the plant availability. The meaning of this is that, see, you can modify any process parameter. Wireless helps you because there is no limitation for installations carrying the cables, and that way you can increase the plant availability. Means plant you can run. Say for example in the year, if it is running for in the 365 days, if you are running for say 350 days, so you can increase the 350 to 360 also. So that availability will be there. Then health of the instruments can be monitored effectively because of wireless. So these are the some benefits of wireless. And now it is used in the plants, but only uh, presently it is used for very critical locations. Critical locations where as I told, difficult to reach locations and all that vibrations is measured nowadays through wireless system. But slowly, slowly it will be used in the plants. Especially you can see in the refineries. There are so many storage tanks, and they are located at a very remote areas. So it is difficult to reach to that because it's look like a jungle only. Forest in the raining season, you see the grass and trees, and it is difficult to reach for the operators or any human being. So this helps tank level or tank monitoring. So that these are the advantage, and even in the pipeline also, which are passing through the very remote areas. So there also that monitoring also is through wireless. So I think you'll get more information on this nowadays.
सर स्क्रीन शेअर करा. हॅलो,
हां, येस.
पीपीटी शेअर. हां, हां.
करतो, करतो. So we have seen this adaptation at RCF of the this part we have covered now. Now we'll switch to the other presentations. I will close this. Um, just minute. So just minute. So we were discussing about compressor vibrations and the probes which we are talking are you can see here. Here. Am I audible, madam? Hello. Hello.
You are
Yeah.
audible, sir.
So we
You
were
are audible.
talking about that system is this one, and this is what basic we have seen yesterday. Motion of the body about reference point and this definition we have seen. So in the vibration basics, this slide is very very important as far as when you are attending any aptitude test interviews. So vibration is to and fro motion of the body from its mean position. Vibration is measured mainly by its amplitude and frequency, and mil is the unit. So these are you mostly when we students are opening the topic. I know vibration sensor. So इंडस्ट्रियल प्रोफेशनल स्टार्ट आस्किंग यूनिट आपको पता है क्या क्या है कैसे मेजर करते हैं सो लाइक दिस so this get direct help to you. This I have seen yesterday. FFT, Fourier fast transformer, how it helps to diagnose the problem. So this I'm going ahead. Hmm. So what we're talking, this is the vibrating body proximeter, and this is the system vibration monitoring system here card. And I told you that vibration signal is coming here, and normal active range and counter inactive range, and proximate transducer we discuss. In that you see here demodulator and oscillator and their functions are mentioned here. See, this is the proximeter. Proximeter means actually this is the proximeter, and this is the what probe. This is the probe side. So the proximeter consists of a demodulator and oscillator which generates RF signal. So RF signal is generated here. This yesterday we have discussed. And this is actual picture. Actual looks like this way. This is a proximeter, extension cable, normal cable, and this is a connector, and this is the probe. So this you keep in mind. Mhm. Vibration probes types: radial probe, axial probe, thrust probe. This is a shaft probe. So these are vibration of turbine protection. You see how many points here, vibration points are there, and this is the system. So you have seen in the picture also. This is the what old system of Bentley Nevada vibration monitoring system, where you can see all these vibration points are coming here, and of that particular point, one system is this. Like this. Now latest is this. As I told, it's a digital now, so you will get a graphical as well as your value will be displayed here. This way systems are there, and these systems are redundant also. This we have talked: gap signal, units, alarms. This was our earlier system. Latest I have shown with the digital display. This we have seen. This is also we discuss. So this is about the wireless vibration or vibration system in the industry. This we have seen. So I think this is about the vibration. If you have any question, I think we'll address that question. Hello, 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 hello. Am I audible,
Hello,
madam?
hi.
Any question? Any question? Just because I have finished industrial wireless or wired vibration setup, how it looks like and all. If you have any question, uh, then I can elaborate on this. Hello.
Hi, yes, sir.
Any question?
Morning, sir. One student is having questions, sir.
Please, please.
Hello, sir.
Hello.
Sir, one question is there.
Huh.
How to measure earthquake?
How to
Earthquake vibration?
earthquake?
Yes.
That is a seismograph. That is a different. That measuring principle and these principles are separate. We cannot measure the earthquake vibration using our probe. Hello,
Yes,
earthquake
sir.
measure is a separate measurement. Okay. So your question is how to measure this earthquake. Hello.
Yes, sir.
But then I will be update you some other session now because I have not prepared for that because we have not in the RCF or in our this profile we were not having that type of instrument in RCF. So we are not much because these instruments are in the environment and other ministry under government control. So I will collect the details and give sometimes I will share with you, but now not now. Sorry. Hello, 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 hello. Am I audible?
Yes, sir.
Sorry that we'll separately address. Now I don't have because we have not worked on that instrument, and we are not using in our area of work. Hello, hello. Seismic vibrations
Yes, sir.
will share you some other time. I will share with you, right?
Okay.
So now you can see here one picture I am showing you. You can see this open compressor here. Rotors and shafts are for maintenance open, and you see this is the what vibration probes are there. You see here is installed here. You see here, and from there you can see signal goes to the proximeter. Proximeter from here. So this way it is there. So this is JB, and on the JB the signals are coming, and this is the probe. You can see here vibration probe, proximeter probe. Proximeter is this side, but this is the what sensor. So I think That's all for vibration.
Okay, sir. Thank you very much.
Okay. Thank you.
So we will meet for tea at 4 p.m. Okay?
Right, right. That is for on wireless.
Yes,
This
yes.
is
Yes.
yeah.
Okay, sir. Thank you.
Thank you. Thank you.